Hi, we're going to do a test of hypothesis about a population proportion. This is actually the first problem from the lesson 6 Wiley Plus exercises. It's chapter 4, exercise 120. The values that you are assigned may be a little different than mine, so don't be concerned that the numbers I get may be wrong in your case. Just follow the procedure that I'm doing. Okay, we are testing whether our true population proportion is 0.5 versus the alternative that the true proportion is greater than 0.5. They want us to use a sample statistic of 0.55, and they're asking us to repeat the test 3 times using different sample sizes. Okay, so I'm going to enter StatKey and test for a single proportion. Okay, first of all, StatKey defaults to a null hypothesis of 0.5, which is perfect because that's what we're using for our test. Okay, now I have to edit the data. All right, we want to specify that our p-hat value was attained using a count of 55 out of a sample size of 100. Okay, next I click on right tail because the alternative hypothesis has a greater than symbol, and now we generate 5,000 samples. Okay, there we go. Last thing I need to do is enter our sample statistic value in the cutoff. Okay, we see that we get a upper tail area or a p-value of 0.182. Okay, I'm going to enter that, 0.182, and they want us to indicate if the results are significant at the 5% level. This is much larger than 5%, okay, 5% being 0.05. Since our p-value is large, we do not reject the null hypothesis, so I'm going to indicate that the results are not significant. Okay, moving on, let's repeat the test. And this time we're going to use a sample size of 5,000. So I'm going to reset the plot. We edit data, and in this case the numerator of p-hat is 275 and the sample size is 500. Okay, again it's a right tail test. We generate 5,000 samples. Okay, I specify 0.55 for our cutoff, and this time we got a much smaller upper tail area or p-value. So when I record that, we get 0.014, and since this is smaller than our significance level alpha equal 0.005, the results are significant and we would reject the null hypothesis. Okay, now moving on to the last sample. Okay, reset the plot, edit the data. Okay, this time we have a count of 550 out of 1,000. Okay, specify right tail, generate 5,000 samples. Okay, and then specify a cutoff at 0.55. Okay, notice how tiny our upper tail area is now from using a much larger sample size. So since our p-value is very small, we would reject the null hypothesis, and we have a very significant test result here. So which provides the strongest evidence for an alternative hypothesis? C. Anytime you use a large sample size, that is going to give you more significant results. And sure enough, we got all the problems correct. So I hope this helps. Bye-bye.